Welcome to the Gresty Academy 7 must-know college entrance exam questions on Limacons and polar graphs. Okay, so let's get straight stuck in. A Limason is any polar equation of the form r equals a plus b cos theta or r equals a plus b sine theta. And they split nicely into three different types. Type 1, a less than b, that is what we call an inner loop Limason. And we'll see one of those later. A equals B, that is a cardioid, and we've already done a video on that, but we will do some more of that again today. In fact, this one here is a cardioid. And 3, if A is greater than B, then our Limason is not an inner loop. It's either dimpled or it's convex. Okay, now the other thing that we have to look at is our all stations to crew here, and we can see that the sign of sine symmetry is around the y-axis, i.e. sine is positive here and here and negative here and here, and likewise cos is symmetric about the x-axis in that cos is positive here and here and negative here and here. So we want to look for symmetry about either the y or the x to see which one it is. Okay, now basically how do we find the a and the b? Well, we have the maximum value of r and we have a minimum value of r, and a is equal to r max plus r min over 2, and b is equal to r max minus r min over 2. Okay, and just one other thing, and we will look at this in a minute, but the inner loop Limason, we actually can have r being negative, so you do have to be a little bit careful about that. Let's have a look at question number 1 anyway. Okay, so we can see that this is symmetrical here about the x-axis, so therefore we know that it is of the form r equals a plus b cos theta, because there's symmetry about the x-axis. Now, let's have a look at r max. Well, r max is clearly here, and that is 1, 2, 3, 4. So r max is equal to 4, and r min is basically when r min is 0, so r min is equal to 0, and therefore we have that a is equal to r max plus r min, 4 plus 0 over 2 is equal to 2, and b is equal to r max minus r min, b is equal to 4 minus 0 over 2, which also equals 2, and therefore the equation of this is r equals 2 plus 2 cos theta, which is a cardioid because A and B are the same, and it's got that lovely heart shape to it. Okay, so that's question number 1. Let's move on to question number 2. Question 2, what's the polar equation of this Limason? Okay, so we know that it is symmetrical about the y. We can see that. So therefore we know that it is of the form r equals a plus b sine theta. Let's have a look at r max. 1, 2, 3, 4, 5. That is the maximum value of r. So r max is equal to 5. R min in this case is equal to 1, so R min is equal to 1, and therefore we have that A is equal to 5 plus 1 over 2, and B is equal to 5 minus 1 over 2. Therefore the equation of this one is R equals 3, that's A, add 2 sine theta. So that is the equation of this one, and that is a dimpled Limason because you can see it's got a small dimple there. Okay, let's have a look at question number 3. What's the polar equation of this? Now, this is an inner loop one. These are quite beautiful, these are. First of all, we have symmetry about the y-axis. So we know that it's going to be of the form r equals something and something sine theta. But we just have to be a little bit careful here because we can see that here our Limason is going southwards as opposed to northwards, which means that it's minus sine theta as opposed to plus sine theta. So the general equation of this is a minus b sine theta. Now there's another problem here. We can see that r max is this point here, 1, 2, 3, 4. So clearly r max is equal to 4. But what about r min? You might think that r min is 2, but actually r min is not 2 because this point here, and we'll look at this later, is basically found when we have theta equals pi over 2, i.e. theta going up that way. So in actual fact, the minimum value of r is minus 2. It's going 2 in the opposite direction of the theta. So the minimum value as r is minus 2, and therefore we have that a is equal to 4 plus minus 2 over 2, and b is equal to 4 minus 2 over 2. And so therefore we have finally our equation here will be r equals, well, a is equal to 1 and minus b is equal to 3 sine theta. And that is the equation of this third one. Okay, let's move on to question number 4. Sketch the portion of this limacon r equals 2 plus 3 sine theta for theta is contained in 0 to pi. So now we're only looking at specific part of the domain. Well, first of all, let's just check that this curve is this one that we've got here. So basically we know that R max is this one. It's just a good bit of practice. 1, 2, 3, 4, 5. So we know that R max is equal to 5. And we know that R min, because it's an inner loop limacon, R min is equal to minus 1. This one, of course, is always minus on an inner loop. And therefore, we would know that basically R is equal to A, which is 5 plus minus 1 over 2, which is 2, add 5 minus 1 over 2, 3 sine theta. So we know, yes, that equation there is indeed the equation of that. But let's have a look. We only need it from between 0 and pi. So let's have a look. When theta is equal to 0, then we have R is equal to 2 plus 3 sine of 0, which equals 2. And when theta is equal to pi, that's the other side of the domain, then we have R is equal to 2 plus 3 sine pi, which also equals to 2. So therefore, we know that this point here, i.e. theta equals 0, R is 2, and this one, theta equals pi, R is 2. We know those 2 points are part of the domain, but is it this bottom bit or is it the top bit which is contained in this domain? And to find out, we need to make a theta be somewhere in between 0 and pi over pi. So let's say theta equals pi over 2. And there we have R is equal to 2 plus 3 sine pi over 2, which is equal to 2 plus 3, which is equal to 5. So we can see when theta is pi over 2, the value of R is 5, therefore that point is included as well. And finally now we can draw the portion of the limacon which is between 0 and pi. That is theta is 0, that bit is theta is pi over 2, and that bit is theta equals pi. And that black bit that I've just sketched, that is the portion between 0 and pi. Now let's have a look at question 5, and you might be forgiven for thinking that question 5 is identical to question 4, because we can clearly see that this is the same sketch as that. And yet our equation, R equals 2 plus 3 sine theta, is now R equals minus 2 plus 3 sine theta. Well, they create the same curve, except this time when we look at the domain, we will see it sketches a different portion of it. So let's have a look again at theta equals 0. Well, that gives us R is equal to minus 2 plus 3 sine 0, which is 0, i.e. R equals minus 2. When theta equals pi, we again have here R is minus 2 add 3 sine pi, which again is minus 2. So we've got to be a bit careful here. Right, so when theta is 0, i.e. going in that direction, R is minus 2, which is that point. So that point there is theta equals 0. And R is minus 2. When theta equals pi, i.e. when theta points that way, R is minus 2, which means R is 2 that way. So this point here is theta equals pi. And what about in the middle? We also have to look at theta is equal to pi over 2, i.e. R would be minus 2 add 3 sine pi over 2, which equals 1. Therefore, we now know that this bit here, where R equals 1, is where theta is pi over 2. And therefore, between 0 and pi, for minus 2 add 3 sine theta, as opposed to 2 add 3 sine theta, it's this bit, the other half of the curve that we just drew in question 4. Okay, so that one there is question 5. Let's have a look at question 6. Sketch the portion of this limacon for theta going only from pi over 4 to pi over 2. Well, okay, well, let's just check. It's always a good idea to check. R is 3 plus cos theta. Well, we can clearly see there's symmetry around the x, so we know that it's going to be cos theta. We know it's pointing that way, so it's plus cos theta. 1, 2, 3, 4. We know that R max is equal to 4, and we know that R min is equal to 2. That's this one here. Therefore, we know that R is equal to A plus B over 2, which is 3, add, and 4 minus 2 over 2 is 1. cos theta, so we know that's right. Let's have a look. When theta is equal to pi over 4, then r is 3 add cos pi over 4, which equals 3 add 1 over root 2. And we just got to be a bit careful here. Let's have a look at these lines here. Well, that line there is 15 degrees, that one is 30 degrees, that one is 45, which is pi over 4, and so therefore we need to just follow that one. That is our start point. R equals 3 plus 1 over root 2, and theta is pi over 4. And let's have a look at theta is pi over 2. When theta is pi over 2, which is the other side of our domain, r is equal to 3 add cos pi over 2, which equals 3, and so therefore pi over 2 is up here. That point is 3, and so therefore the portion of the limacon for this domain here is only that little bit there. And we can actually see, just as a matter of interest, that there's no dimple here because this is greater than 2 times that. Okay, so that's question 6. Let's finally have a look at question 7. This is a bit of a fun one. So we can see here, question 7, this looks like an inner loop limacon, and it's either of the form, and I apologise for my drawing in advance, it's either of this form rotated 45 degrees anti-clockwise, or it's of this form rotated 45 degrees clockwise. Both of those would produce this. So first of all, let's have a look what this one and this one would be. Well, this one, we know that there would be symmetry about the x-axis, so that one would be r equals cos theta, and we just have to look at the maximum and minimum here. Well, the maximum is this, which if we go around this circle here is 5, and the minimum is this one, which if we go around the circle is 1, and so therefore we would know that r for this one, the unrotated limacon, is going to be 2 plus 3 cos theta, or alternatively, if we look at that one, then it's going to be r equals 2 plus 3 sine theta. But of course, this one and this one both need to be rotated. That one would need to be rotated anti-clockwise, and that one would need to be rotated clockwise in order to get this. So there are actually 2 answers here. So how do we rotate anti-clockwise by pi over 4? Well, if we rotate anti-clockwise by pi over 4, then all we do is we replace theta by theta minus pi over 4, and if we rotate clockwise by pi over 4, then we rotate theta by theta plus pi over 4, and therefore the equation of this inner loop limacon is either r equals 2 plus 3 cos theta minus pi over 4, i.e. the cos one rotated 45 degrees anti-clockwise, or it's r equals 2 plus 3 sine theta plus pi over 4, i.e. the sine one rotated 45 degrees clockwise. So both of those are the answer to this rotated one, and that concludes our video. Hope you found this useful. Hope these questions come up on your exam. If you have, then please subscribe to the Gresty Academy YouTube channel, and if you like this video, please press the little thumbs up button. Thank you very much indeed.